23, what massive object is likely in the middle of the central bulge? A supermassive black hole. Supermassive black hole. 24, all active galaxies contain a feeding supermassive black hole. 25, the blank and blank swirling around a feeding black hole can give off light, gas. What'd y'all put for that? Gas and dust. Yes, according to the notes, gas and dust. 26, one extreme example of an active galaxy is a quasar. The extreme redshifting of quasar shows that they are very distant and very old, which currently seems more likely. It looks like, which one of those did y'all pick? Do we have more falling apart or merging going on out there?
Merging.
Merging is correct. So that first statement is better. This one here. All right, 29, gravity. Gravity can pull galaxies together and cause them to merge. They will likely pass through one another several times before they come together as one galaxy. And then the Milky Way is clumped together with about 30 other galaxies known as the local group. 32. Clusters will blank with other clusters to make, so let's say clusters will clump or cluster with other clusters to make superclusters. Now we're talking about galaxies. So galaxies tend to clump together and those clumps tend to clump together. Our local group is part of a larger clump, if you will, known as the Virgo supercluster. And we recently discovered that is a part of something even bigger called Laniakea. 35. There are two kinds of star clusters, open, globular and open, and that's something that honors needs to know only. 36, the stars in both were born at the same time and held together by gravity. Once again, that's an honors thing. All right, numbers. All right, time it takes the sun, and just somebody call it out. Time it takes the sun to go around the galaxy. What is it? 200 million years. 38, the length of our galaxy in light years. 100,000, is that what I heard? Light years, okay. The distance to the closest large galaxy, 2 million light years. The approximate number of open star clusters in the Milky Way. Y'all know that? Remember in the notes it said 1,100-ish. So the closest number here, the 1,100, that last one's probably the best one. And the approximate number of galaxies in the local group, 30. Now the 140 goes with, of course, globular clusters for you honors folks. All right. Galaxies and supermassive black holes within them. What massive object seems to be in the middle of most galaxies? A supermassive black hole. If their objects are so common within galaxies, what might the hint importance be? They might be an important part of the creation of that galaxy. It might be important part of it developmentally. And it should say if these objects. How massive are they compared to typical black hole? Millions to billions of times more massive. Why are some of these objects considered active? Because they're currently, quote unquote, feeding on stars and or dust. Remember the accretion disk and the galactic jets when they're eating, those things shooting from the front, top and bottom of them. Is the Milky Way currently active? No. The expanding universe, who is famous for measuring the motions of galaxies? Edwin Hubble. According to Hubble, what directions are most galaxies moving? Away from us, and they're also moving away from each other too. Remember, the universe is expanding. What does Hubble's law state in general about galaxy speed versus distance? All right, the closer galaxies are going to be moving slower, and the ones further away are moving faster. So if something is 4 times as far away, it's 4 times faster. If it's 2 times, it's 2 times as fast. So the farther a galaxy is, the more quickly it's moving. 50, how did his findings support the idea of the expanding universe? So if everything's flying apart, if everything's moving away from each other, it sounds like the universe is expanding. How did it support the idea of the Big Bang? In the same way, if things are expanding, then that means they used to be closer together. And if you take that to the extreme and run time backwards, That means that it looks like everything came from one point, one event known as the Big Bang. 51, compared to the speeds of 3 galaxies that are respectively, compare these speeds 25, 50, and 100 light years away, according to Hubble's law. 25, 50, and 100. So notice that 100 is 4 times farther than 25, so it's going to be moving 4 times faster than the 25 is. All right, 50 is twice as far away as 25, so it's going to be moving twice as fast as the 25. Okay, and you could go the other way and say the 25 is moving half the speed as the 50 and 1/4 the speed of 100, but you get the point. The further away it is, proportionally, the quicker it's going. All right, the Hubble Deep Field, why did they choose this patch of space? Because it seemed empty. How much of the sky did it show? About a grain of sand held at arm's length. It shows the size of about a grain of sand held at arm's length. What was found in the picture? About 3,000 galaxies. An amazing picture. 55. Compared to the apparent visual age, compare the closer galaxies in the famous picture to the ones that are deeper in space. So the closer galaxies are going to look older, but they're going to be younger. And by contrast, the ones that are really deep in space, they look like they're babies still. So it's like we're studying the early universe. The distant ones look younger, but currently they're probably the oldest of all. So you can see that it's kind of confusing, but it also makes sense. The light has traveled a long time, so they're a lot older than they look now, those distant galaxies. All right, honors only section. Right, globular or open beside these things. They are much older. Everybody call that one out. Globular, they tend to have more blue stars. Open, these are about 140 of these. Globular, the Pleiades is famous. Open, they are spherically shaped. Globular, born together and gravitationally bound. Both of them. All right, write the zodiac in order. Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, Aquarius, and Pisces. All right, show the Earth tilt with an axial line going through it. Let's try to spell those words right. And where the North Star is. So look at your drawing of the Earth. It should be tilted to the side with like a line going through the Earth so you can see that it's tilted to the side. And right, if you kept going straight out the top of the Earth along that line, the North Star is about there, right above it. Here, I think you can see it back here. So we have kind of this thing. The North Star would be out here and this point. Yes. The North Star would be about there. All right, everything's flipping backward. That's messing with my brain. All right, now, as things change, eventually the North Star, this will still be here, but this will be the new North Star in 13,000 years because it takes about 26,000 years to go around. Remember, it wobbles, and that wobble takes a long time, but the whole time it stays 23 degrees. This angle stays the same, like that top that was spinning, but eventually it's going to be over there, and then by 26,000 years, the North Star will be the North Star again. Okay. I noticed that there are a couple sections. There's a few notes that was not covered on this for honors. In the honors section, you will find it under globular clusters. You'll talk about how the globular clusters and how we found out where we are in our own galaxy. You'll want to check that out. And the other thing I noticed that wasn't on here is on galactic evolution. This is everybody, including CP. Galactic evolution. There's a couple notes that were not covered on here. It's the second page. And it's the one where it talks about we're going to run into Andromeda and probably become an elliptical galaxy, that kind of thing. So look at those two notes as well. All right, let me stop my recording here.